this video, we're going to show how to generate a normal probability plot. We can take any number of the quantiles from any normal distribution and plot them against the same quantiles from any other normal distribution, and we always get a straight line. Let's see how this might work. First thing I'm going to do is I'm going to generate 19 equally spaced values. These are going to be the percents for the quantiles. 5%, 10, 15, 20, 25, 30, up to 95. So 19 of them. I'm now going to generate the quantiles for those percents for our normal distribution with a mean of 2 and a standard deviation of 3. Notice we have a bunch of 19 values. The minus 2.93 is the 0.05 percentile of this normal. The 6.93 is the 95th percentile of this distribution. Now I'm going to do the same thing with a standard normal. We're using standard normal, but it could have been any other normal. Notice we get 19 different values. Now all we're going to do is we're going to plot Q23 against Q01. I'm going to let Q01 be the x values and Q23 be the y values, though it doesn't really matter in this case. Let's see what we get. Absolutely straight line. But what if we have a sample of data points? We don't really know the distribution. So we have some data points, and we'll have these sample quantiles of a normal distribution, and we'd like to know if the data points come from a normal distribution. If we do the plot that we just did, we won't get a straight line. But if the data points came from a normal distribution, the line should be almost straight. The plot we generate is sometimes called a normal probability plot. Let's see how we might do this. What we're going to do is we're going to pick 14 points instead of 19. We really could have picked anything we want. So the first thing I'm going to do is I'm going to generate $14 points from a normal distribution with mean 2 and standard deviation 2 randomly. I'm going to sort them because our normal probability plot should always go from the lowest value to the highest value. And I'm going to round it so it looks a little better. So here are the quantiles for this particular normal distribution. Well, actually, it's the random numbers that I'm generating, 14 of them. I'm going to plot this against a standard normal. So what I'm going to try to do is I'm going to try to generate 14 standard normal percentiles to plot against this. The question is, which ones? And in general, what we're going to do is, if we have any number of values, say n, what we could do is the first value, the percentile that I'm going to get, will be 1 minus 0.5, in this case over n of 14. The second one will be 2 minus 0.5 over 14. In R, this is pretty easy. What we could do is we could generate the vector. In this case, it'll be 1 to 14. We're going to do my little conversion. The x minus 0.5 over n was 14. So these are the actual percentiles I'm going to try to find. And then I'm going to use the qnorm function to find the actual quantiles for these. for the standard normal. I'm going to round them and just display them. And basically what we're going to now do is we're going to plot these numbers against the sample that we have up here. So this is XSamp, and this is called Q01. And my plot is going to be pretty simple. Not quite as good as we had before. You'd have to look at this and say, does this look something like a straight line? You know the code was just right here. Q0, those are the X's. XSamp, those are the Y's. Notice these are the theoretical quantiles. These are the sample points. And here's the title. It happens that there's a built-in R function that does this. It's called the QQnorm function. Now here's XSamp. Remember, we took our sample, but this would be our data values. So these are the data values that we had. It could be any number of them. The built-in function is called QQnorm. And what it does is it generates the exact same graph that we had before. But you didn't have to worry about the standard normal quantiles. As a matter of fact, it winds up that the QQnorm XSamp is a list in R, and part of that list is actually the Q01, which were the standard normal quantiles. Here's what we plotted against. And here is, it's called QQnorm XSamp $X. Let me take the graph away. And notice what you have. Here are the exact same values that we generated before. They're not rounded here yet. And that's how we might generate a normal probability plot with R.